If you need me to move my machine.
No, we don't need so much.
Cool.
Hey, how's it guys?
Howdy.
I'm Jonathan, this is Herman. We're from a company called Gamelogic. We develop tools for Unity, specifically for the Gamelogic aspect of games. So just a little bit about where we came from. We both work for a game development company in Cape Town called ICE. And after that project was finished, Herman came up to me and he said, he asked if I'd like to get involved with game development tools. But actually to run the business focused on creating tools instead of just as spin-offs from creating games. So basically we're looking at creating a main product line of tools to help developers implement the rules for the games. So tonight we just wanted to introduce ourselves to you guys and talk to you a bit about our first product, which is called Grids. So Herman's going to take over and chat to you a little bit about where Grids came from and what it's all about. And then we've got a video to show you and then answer any questions that you guys have. So yeah, over to Herman. Thanks for having us.
Yeah, so Grids is our first product. It's basically a library for Unity to help you make set up grids in games. All types of grids, hexagon, triangular, rectangle, and so on. So the basic idea, while we're still busy with our project at ICE, we had a break between Christmas and New Year. And I just wanted to work on something small that I've been playing with. So it was a game based on an hexagon grid, and to my surprise it was a little bit more difficult to set up than I thought. So I got stuck in a lot of details, getting hexagons onto the screen, figuring out which one was clicked on. So I went over that time, and a lot of the game also had some algorithms like finding shapes of connected hexagons and constructing the grid in a specific shape from the beginning. So I got a little bit obsessed with the technology of setting up grids and so on. And there's not a lot of information on the internet available. Everyone solves a problem for their specific game. So I wanted to get into a more general thing that you could use and basically figure out a good way to think about problem solving on an X grid. And then it grew from there, and I looked at other types of grids, triangular, and you'll see now some more exotic grids as well. Yeah, that's basically the library. So one of the things that this is a very simple example just to say, like it doesn't stop at the normal grids. This is called a Cairo pentagon tiling. It's basically you can see each cell has 5 neighbors, and this is the lights out game, which is basically it just switches neighbors, and the idea is to clear all the cells. So with the technology that we bring, we hope that people will think of more ways of making games that people haven't thought of before. Yeah, that's basically that. So we'll show you the video now.
Did you make that video with your fake engine?
Yeah.
Cool.
It's not recommended though.
The stuff that you were doing there, I saw some of your grids. It looked like you mapped like some sort of larger texture over the entire grid.
It's actually it's a tile set. I think there are 13 tiles in that set. Basically, it chooses a random point, green or blue, where the vertices of the axis meet, and then it chooses the right tile to place at that point, so that it's basically matches, blends smoothly.
And is that sort of? I originally, when you told me about it, I got the impression it was more of a pure logic tool. What are you using there to render? Is that one of the tools?
Most of those examples are actually in GUI stuff. So it's basically, it is a data structure. So you're responsible for displaying it on screen. There are functions that to make it easy to map to the screen and handle resolution and all that stuff. But it doesn't do any rendering itself. But it does have functions to figure out in good ways what to render, like in that case where the data structure supports vertices, logical vertices, not mesh vertices.
Currently, is this on sale at the moment?
Yeah, it's in the Unity Asset Store for $100. But we're still looking for feedback. So anyone wanting to try out a copy must please just send me a mail or hit me on the forums and we'll give you a copy for free. So it's yes.
Have you guys have you got any games that you guys are going to develop with this? Or just want to stick to tool building, or some ideas you want to expand on?
I think for the moment we'll stick to tool building.
We definitely will look at making games at some stage with the tool. But the focus at the moment is improving the tool and getting as many people as we can to make games using it. But definitely we see ourselves making games in the future. At the moment there's not enough time to do that. So
I saw you had like a procedural way of generating maps there. It's like sort of like a fractal or something. So it looked like walls and pathways and things.
Oh yes, there's basically there are two maze generation algorithms there. The one was on an X grid, which is, it starts off with a path and then intelligently replaces patches. So that there's always still a path between the beginning and the end, but the patches themselves are random. So as you run the algorithm a little bit, it goes into a maze.
Yeah.
And the other one is it's a very old maze generation algorithm that basically works by adding walls. So in that example, it's actually, the maze itself is on a triangular grid, but the edges is on a rhomboid grid. That's the one with the diamonds at different angles. So yeah, it's interesting because normally games that work on edges, they just render the lines. But we actually provide a way for you to use styles so that you can make more interesting walls and sections.
Yeah, obviously because you'll use that to generate maps for a Diablo sort of game. So you'll have trees that fit into where the walls are, you can't go through them and everything, and you can make complex 3D assets fit into those patterns, and that would be top down.
Yeah.
But does your library then support structures or paths for instance, AI to know what's the best way around obstacles and things?
It does. It has the concept of connectedness, and you can have different types of connectedness, and then a path is then one type of that. So there is a basic A-star path finding algorithm, and you can set up weights and everything with it. But it's not optimized, but it's quite easy to roll out your own or use with a different path finding algorithm. So it's definitely something we thought about.
I think that would be a cool thing to add to the video if you can. If you actually show like enemies on that grid trying to battle each other or something.
Yeah, no, definitely. You must see our list of things that we have planned for version 2 of the video. No, it's really, there's lots of stuff we want to still show. Obviously, it took a little bit longer just to get that done than we thought, but as time goes on, when we have a blog that we keep updating, so if you want to check it out, follow us, and then...
And is it only 2D or can it be expanded into 3D volumetric shapes?
Well, it depends on how you want to do it in 3D. The basic data structures are 2D. But the thing that does the coordinate conversion is totally separate from the grids.
Okay, so it can do distance in 3D space.
Yeah.
Okay.
In fact, the way we've set up those examples, they are actually converted to 3D space, and it just happens to be the way the camera is set up that you see it as flat. But it's easy to work with height maps, for instance, and it can be totally separate from your grid. So your grid doesn't have to know about your world. So just your little piece that figures out how the world relates to your data. Okay.
Yeah, I'm talking more about like universal planetary, like EVE Online space game sort of thing.
Yeah. Well, for that, they aren't. It's a lot more difficult to tile space. The most obvious way to do it is obviously with cubes. And that's pretty straightforward. We didn't, that's not part of the problem we try to solve here. Maybe something to look at in the future. I mean, people are always a bit more interested in 3D things, but we have some other ideas as well. And that's basically to have our grids work on different surfaces. There's some very interesting games on spheres and toruses and stuff like that. So that's one direction we might go in the future. We'll see. There's another grid package available on the Asset Store that actually does grids in 3D space, or the way that you talk about. But the type of thinking there is quite different from our thinking. I think from the beginning we kind of had abstract puzzle games in mind, and because it's abstract, you can do a lot more than that with it. But I think that will always be our base.
The little demo game that you had had some odd sort of tiling. What other shapes can you test like arbitrary shapes?
Yes.
Or is it just sort of specific things that can be tiled?
Well, not arbitrary. There are some rules. Basically, there are only two types of grids where all the tiles look the same: square and hexagon. Most other regular grids are basically those that you just dissect the tiles in certain shapes. Now, any grid that you can make in that way can be used with our thing. We just submitted an update today, which allows you to just specify the endpoints of the polygons of either the square or the hexagon, and then it will just work. So all you have to do is basically work out where the points are, and then make the tiles, and say our neighbors are connected and stuff like that. But it's quite flexible.
If you're going to map it onto a sphere, one thing I would ask is the pathfinding recognizes that the edges connect across. So you find any position on the sphere to any other position on the sphere.
Yeah. Right now the interface of all the grids is basically just graphs. So they don't really know about distances, or all that they know about is how neighbors are connected. So for that part, it's quite easy. Internally, though, it's a different story because we use flat arrays to represent the data. Actually calculating from whatever grid you have where it should fit into that array is probably the most complicated problem. And I think when we get to that kind of on spheres and problems like that, how to store the points in our array will be the most difficult problem to solve. The neighboring problems is not so hard.
But if you don't know the distance, then how do you erase them?
So again, how do you?
Or how do you measure your approximate distance from the target?
The thing is, there's a map that basically converts between coordinates, and the map knows about distances.
Okay.
But the map is dumb in relation, it doesn't know about the structure of different entities.
So you do your weighting in the map, but you do your...
Yeah, so basically,
neighbors in-
when you want to know about where something is in the world, you talk to the map. But when you want to know how things are connected, you talk to the grid.
Okay.
And it's nice, and that's also, for instance, how the animation works. So basically the grid is static, just the dump data structure, and then you change the map dynamically, and then just update the positions. So,
What is your dev log? Actually, what's the URL? Was it? Sorry, I'm sorry. Is it the same as that thing?
Just yes.
yeah, there's a slash block where and we have cool stuff on there at the moment, how to make seamless hexagon tiles, which is quite difficult. And we'll keep updating. Like I said, we kind of want to inspire people to think, of different ways to exploit what we can offer. So we're always trying to think, what can you do, and why aren't people doing it? One reason is maybe it's boring, but another one is maybe it's difficult. So we try to see what we can do about the lost.
I read the hexagon thing, I didn't understand it.
Okay, I'll rewrite. All the examples are included with the package as well. There are now 25 examples.